I'm really excited. I'm going to talk to you today. I guess I should say who I am. I'm research faculty at Boston University. I'm a cryptographer first and foremost. And I want to tell you about a project of deployment of cryptography, in particular multi-party computation, that is for social good, which is the tagline that I like to use outside of this room. I guess in this room, it's a little bit, we can complicate that notion and maybe think that this is not the best way to frame it. And this has been work that I've been doing with some colleagues, both within the cryptographic community, Keenan and Mayank, as well as folks in the art museum world. I'll talk a little bit more about who they are in a moment, Jen and Mia. And what I'd like to do today is tell you the story of this deployment of MPC. And I'm going to tell it to you twice. For those of you who have heard this talk at RWC, I apologize for the repetition. Hopefully, we'll find new ways to frame it as well. So in 2021, losing track of time here, I got an email from an organization called Museums Moving Forward, or MMF for short, because they were interested in seeing whether or not they'd be able to integrate multi-party computation into a project they were currently thinking about booting up. MMF is an independent organization of art museum professionals, and they're devoted to envisioning and creating a more just museum sector by 2030. And it's made up by people kind of throughout the entire art museum world that have different perspectives and are trying to kind of do some organizing work. It's like an easy way to think about it. And up until this point, when they reached out to us, they had been doing a lot of qualitative methods in order to understand some of the issues that were happening in the art museum world. A lot of interviews, a lot of essay writing, and those kinds of things. And they were interested in trying to integrate quantitative tools into what they were doing. And part of that was to kind of appease some of the people out there who are looking at their work and saying, well, it's not data-driven enough. I want data-driven insights. And they said, okay, well, how do we go about building kind of data-driven insights to satisfy the people, to convince them that there are really issues that are happening in the art museum world? And so what they want to do is deploy out a survey to people who work in the art museum world. They want to send out as many links as they possibly could and try to get all this data about how is your experience working in art museums, and then generate a report off of this and use that to further their own work. And so they had heard about this thing called MPC. They didn't really know what it was, but they sent me an email and said, hey, maybe you could help us out and we can try to do something together. There are a couple of other surveys that we worked with them to deploy as well. One that gathered information from the directors of museums, and one that gathered information directly from HR departments at museums. And one of the things they wanted to do as part of their data gathering is they wanted to ask really sensitive questions. They wanted to ask kind of traditionally sensitive questions like how much money do you make and things like that, kind of the rote examples that we have. But they also wanted to ask questions that were very particular to the art museum world. Are you thinking about leaving your job? How do you feel about working in museums? And these being kind of important sentiments that they were trying to gather at scale, in addition to issues of discrimination and harassment. And they were fairly convinced that there would be a good deal of concern among the people that they were asking, that if their information, their answers was ever leaked, that their employers might actually take reprisal against them or kind of punish them for saying bad things about the organization. There are actually lots of other existing surveys that are going out to these people that people felt actually not comfortable with. They couldn't really say what they were feeling with because they're oftentimes run by organizations that were really tightly linked to the organizations that run the museums themselves. So there's a lot of tension about who got this data and what. And so they said, hey, we want to gather this information. We want it to be privacy. We heard you might be the right people to talk to. One of the interesting things that they required from their deployment is that they were interested in having different outcomes or different outputs of this MPC for different parties. And in particular, we kind of came up with this notion of an organizational report. And what this basically meant is that while they were going to get kind of high-level insights across the entire field, they wanted individual museums to understand how they were doing relative to the rest of the field. So some kind of benchmarking thing. And that meant kind of pulling out the data that was just relevant to one museum, aggregating at the museum level and handing it to them. But MMF and similarly BU, we didn't want to see these organizational level reports. That was kind of sensitive information, and these museums might not actually participate if their kind of localized performance was going to get public. They were actually really concerned about that. So with these requirements in hand, we kind of sat down together and tried to figure out how we could use MPC to help these folks out. So when it came to constructing a system, we were very lucky in that we had a system that BU has been using for the last 10 years or so in collaboration with the Boston Women's Workforce Council in order to measure the wage gap in the city of Boston. What's really the important thing to know about how this system worked is a couple of things. One is that it's in the client server model, so that lots of the different people are going to submit data, but there's actually going to be two computational parties that are going to do the aggregation. And the second is that this is a very particular use case of MPC in which one of the computing parties is not technically sophisticated. These are a bunch of like artists and social scientists. They can't like pull down, build code and deploy it to an AWS box. Like that's not going to happen. And so we needed some way to allow them to participate in computation without requiring them to do technical work. And so one side of the MPC is all done using in JavaScript in the browser. So that one side is run on a server and one side is run on a browser. And so we're able to kind of take this existing code base, spruce it up a little bit, make it kind of the front end look nice for these folks, and then get ready to deploy. When it came to actual data collection, what we did is we integrated just a classic survey library into the front end. This wasn't there before. And so this felt like a natural experience for filling out a web survey. This is called Survey.js. It's like exactly what you've interacted with every time you've taken a survey ever. And then at the end of that process, they would hit submit, and their data would then get encoded and kind of stored particularly for our MPC needs. And what would happen is we'd use a secret sharing scheme. This is just an added a secret sharing scheme. The data would be split into a share that would be held by BU and one that would eventually be held by MMF that we could do computation on. And that was kind of the overarching idea. In order to facilitate these shares going to the right places, MMF wasn't like online all the time. They didn't have a server. So we needed to basically use public key encryption to encrypt the shares that were eventually going to go to MMF. And they'd sit in this repository or this database that was run by BU, but it was all encrypted under MMF's public key. Additionally, in order to facilitate those organizational level reports, there had to be some way to get information from MMF back to these organizations and back to actually everybody who participated in the survey. In order to do this, we need to build a secure channel. And the people who are still filling out the surveys like didn't have identity and they didn't have any public keys. We couldn't do any of the normal things. And so we decided to do something very simple. They just defined a password and we allowed that and kind of just use a key derivation function to derive a key based off of this password. So nothing fancy here. And this key would also get sent over to MMF through the same channel as before. The actual MPC itself is not that complicated. So BU, as I said, we're holding all of these shares in our database. MMF shows up, they download all this information onto their browser, and then locally decrypt all the information. And now we've got shares both on the BU side and MMF side, and we're ready to compute. The actual computation is just a semi-honest gate-by-gate 2PC using correlated randomness, in particular using beaver triples. Really kind of nothing fancy to see here from a cryptographic perspective. Unfortunately, in order to do nonlinear function evaluation in this kind of paradigm, you need correlated randomness, and the library that we had no correlated randomness. And I should say, I'll talk a little bit about this later on. The engineering effort here was mostly me sitting in my house with a blanket over my head, like typing. So while it's certainly easy enough to build correlated randomness into these systems, like I didn't have time to do it. And so instead we kind of decided to do a different approach. We enlisted Kinan, who actually initially wrote a lot of the MPC libraries, to just serve as a dedicated correlated randomness generator on demand. And so there was a server sitting somewhere in Brown's logical domain. I don't think it was physically there. And just on demand, BU and MMF would say, hey, can we get some correlated randomness? And it would just send us some correlated randomness. So at the end of the day, we have a semi-honest, honest majority, free PC. That's as technical as this is going to get. There's really nothing else technical coming. The insights from this survey were really valuable to the folks who are trying to organize within the art museum world. I'm not going to go into all the things here, but I'm happy to talk about it or happy to point you in the right direction if you're interested. Kind of big high-level takeaways for me is that art museum workers are more dissatisfied with their work. Many of them are considering leaving their job or the field entirely because of the conditions of their work. Something that really stuck out for me is that more than a quarter of all museum workers have experienced some kind of discrimination in their workplace, but only half of those workers are actually going to have been reporting that, because they think that reporting it isn't going to do anything. So if you want a good kind of indication that something's gone really, really wrong in a workplace, this feels like a pretty strong signal to me. The data was then kind of released back to lots of folks, lots of stakeholders, including people who took the survey. We did this in two different ways. One is we built a front end on the website which could consume secret shares and then reconstruct a visualization that could then be looked at by organizations. And this is mostly for those organization level reports. And additionally, MMF put together this 140-page report with both the outputs broken down by different identities, but also giving a lot of context around these numbers to understand how they compare to the rest of the US workforce or other similar things. In order to kind of circulate these findings, MMF convened a bunch of different stakeholders to talk through the results and figure out what this means, where do we go from here? And overall, the responses was really, really positive. People were really, really excited. I'm personally really proud that we were able to do this. And I think that MPC actually played a non-trivial role in garnering support and buy-in from people. And I don't necessarily think it's because the MPC itself felt so secure, but rather that MMF had gone out of its way to bring in security and privacy experts, aka me and Mayank, who were able to consult with them along the way and build a system that we thought was going to do a good job of preserving privacy. And that signal in and of itself was probably just as strong as the MPC was. Good. So this version of the story that I just told you is what I like to call the Instagram version of the story. It's very clean and it's very manicured, and it's the kind of thing that you could write up and send to a security venue, and maybe, just maybe, reviewer 2 wouldn't kill your submission. But the truth is that just like an Instagram story, a lot of the mess that goes into creating this kind of deployment is hidden. And when you start to zoom out, you start to see the chaos that actually goes all around the beautiful thing that you built. And so what I'd like to do with the rest of my time today is try to tell you the stories around the deployment in order to kind of allow me to share my experiences of things that went wrong and things that I did wrong, so that when we all together are trying to build systems for folks, where we're thinking we're trying to actually collaborate across disciplinary boundaries, you don't run into the same mistakes that I've made, and we all kind of can start in a slightly better place. Good. So I'm going to use the same structure that I did before, each of the steps of deploying and designing an MPC deployment. And certainly when I sat down to do this deployment, I really thought it was going to be linear. I thought it was going to be like, yeah, this will take 4 months of my time. I'll work on it part-time. It won't be a big deal. But the truth of the matter is that when you work on these kinds of deployments, they never work this linearly. They actually look a lot more like this, where every single time you make a mistake, you have got to go back and figure out, well, what did I do wrong before? How do I need to kind of change the choices that we made before in order to accommodate new information that I've understood now, new lessons that I've learned? So the major kind of first lesson here is that collaborative deployment, particularly cross-disciplinarily, is really, really error prone, and it's inherently iterative. And so if you sit down and you try to say, okay, I'm going to finish this thing in 4 months, you're going to be very sorely disappointed when you find out that you misunderstood the problem statement 2 months in, and now you only have 2 months to kind of hack together a solution. The start of this collaboration was a cold email, as I mentioned, from Mia. And Mia had heard about our work because she had come across the prior visible work on MPC, in particular this Boston Women's Workforce Council. And she'd heard about this from a social scientist that she was talking to. And it turns out that actually 2 years prior to that conversation, I had a conversation with that same social scientist in which I was saying, hey, I'm really a fan of your work. I think it's really cool. I just wanted to kind of say that I'm new to Boston. Let's hang out. And 2 years later, when eventually a real use case for MPC came along, the same social scientist said, hey, I've actually talked to somebody who might be able to help you in this. And they were able to connect us, and we were able to make this work together. And this experience for me has kind of reinforced this understanding that it's important to spend time in non-CS spaces. And I think this is a shared theme across all the talks that we've had so far this morning, is trying to integrate viewpoints and experiences and people beyond the computer science world into our understanding and definitions of problem spaces. When it comes to system construction, I actually don't have time to tell you all the various mistakes that I made, so I'm just going to kind of zoom in on one. I said in fall 2021, we had these initial conversations, and we said, okay, we want to deploy this MPC. It's going to be a survey. Great. We know what we're going to do, and we can start building a system. And so what we did is we recruited a bunch of undergraduates to start building our system. Things were going great. We were making some progress, and they started to build out the system and add some additional features and change the front end and whatever. And our hope was that by the end of spring of 2022, we would have a nice, well-defined circuit that we were going to evaluate on these MPC inputs, right? We want to know, do you need standard deviations? Do you need variance? Do you need medians? Do you need what? We need to understand what the computation itself is going to be. And so by the end of this spring semester, the students were feeling, okay, we're ready to go. We understand the problem space. We kind of understand MPC. Where are these circuits? We said, oh, wait, that's interesting. We actually don't have any circuits that are defined yet. And we went back to MMF and said, it'd be great to actually have these circuits so we can start to implement them and test them and make sure we're ready to go for the fall when we're actually going to do data collection. And they said, oh, we've been really working hard on this, and we've been really refining and working on our survey instrument, and we're feeling really, really good about it. We'll give it to you soon. And so for those of you who don't speak social scientists, survey instrument in this case can be just like recoded into the crypto language as MPC inputs. Right? They were really wanting to make sure that the survey that people saw had the right questions, and they were gathering that information such that museums were going to buy into this project. But what they weren't doing is understanding, or they weren't thinking deeply about what computation they were going to do on those inputs. That hadn't occurred to them. And in fact, it was actually kind of implicit in the way that they normally do social science. They don't need to think about what computation they're going to do. They already kind of have that knowledge, but I needed them to write it down for me so that I could actually put it into circuit format and test it. Right? And so there was a little bit of a gap there. And they said, oh, okay, I think we understand now. We can get these to you soon. So over the summer, we built this front end and things were looking great. We got to fall, and still there was no circuit format for me to actually implement. They hadn't specified what kind of computation they wanted to do. And so I went back and I said, what's going on here? And they said, oh, you're actually going to be really happy. We've refined our circuit instrument so much more. We think people are going to be really bought into it. We've held all these kind of convenings and talkings through. And I said, that's great. I just actually need to know what computation you're going to do. I don't really care what the inputs are. I can change those last minute. I can change the wording on the question. That's not a big deal for me. That's just like a JSON file that I can change. But the circuits, I actually need to test. I need to make sure I don't mess those things up. And they said, oh, okay, we can try to get these to you. But of course, at this point, it's already fall 2022. We're about to hit our data collection window, and we still have no circuits that are defined. For me, this calls into mind this X3CD cartoon, right, which tries to point at the problem of explaining what are hard problems and easy problems in computer science. It turns out it can be really, really difficult to communicate this across disciplinary boundaries. And in the MPC case, this difference between MPC inputs and the circuit of an MPC is really, really highly non-trivial for people who are not used to thinking computationally. And so the problem that we were running into here was one where I was failing to actually successfully communicate what my needs were, what the problems that I needed to solve were in order to make this happen. And the dual of this is also similarly true. As a computer scientist, I was having a hard time understanding what the hard parts of their jobs were. Right? They need to make sure that every single word of their survey felt good to them, right? And it wasn't going to provoke a reaction. That was a really non-trivial process that they spent months doing. But from my perspective, this is trivial, right? This is just wording that you need to kind of fix. You kind of do this at the last minute. And so we were kind of at odds with each other. We weren't sitting down and able to accomplish a collaborative goal as well, because we were both focusing on different hard problems in front of us. So a big lesson here, the first one is like, this is very MPC specific, but the distinction between circuit inputs and circuit structure is very subtle. And I think in general, when it comes to kind of data versus the computation on data, this division is not one that people who don't think computationally are used to interacting with. Additionally, I think it's really critically important when working cross-disciplinarily like this, to recognize the parts of a problem that somebody else is going to find difficult and interesting, and they're going to invest their time in, because that's really going to give you an indication about where things might, from a timeline perspective, work out differently. So fall 2022, we'd already agreed and sent out this email to everybody who's going to take the survey that it was going to open on, I think it was supposed to be November 1st. We pushed back a couple of days, but it was going to be in November. And so at this point, we said, well, we got to do this. We got to collect the data. One nice thing about MPC is we can define the circuits later, right? We can still manage to get this thing to work out. So when it came to data collection, we decided we're just going to go with it everywhere. We're going to use care to make sure we actually are computing things that feel socially good. We gathered 1907 responses from about 10,000 links that were sent out. So a relatively large number of people and a relatively high response rate. And I gathered all this data, and then as we kind of iteratively understood what kind of computation we were going to do, I was sitting and writing up these circuits and I was testing them. And I realized, wait a minute, one of my data points is lost, right? I expected a data vector of 420 entries. I only have 419 entries, and I don't know where one of them has gone. And it turns out when I went back and looked at the survey, I decided to, there's a question about the income, the amount of money you make from a museum. I had made the mistake of coding this as text when it's in fact a numeric value. And I thought I was so smart, and I put in a regex to make sure it was going to be numeric. But I actually never cast this thing from a string into a numeric value. And so what happens when we took this answer from the survey and we pushed it into an MPC library, it tried to secret share a string, and the library just silently failed. It created no secret share whatsoever, and it pushed a null value into my vector, and it moved on with its life. At this point, we've collected data from 2,000 people. We can't go back and ask them anything. We're just toast, right? I have made a very stupid classic CS error, and as part of that error, I managed to throw out a really significant, important part of the data collection. And there's a lot of things that we can learn here. One might be that don't have CS faculty write code, but instead we're going to take a different takeaway here, which is that when it comes to testing your MPC, if you don't have circuits to test on, it can be really, really hard to spot issues in data collection. MPC is not set up to do this. You can't see the data. It's hard to open everything and see what's going on. And so if you kind of push the data collection before your actual MPC, you can run into some serious issues. When it came to the computation, I didn't lie to you. Everything worked the way that I told you. I just didn't tell you a lot of the details. The first detail here is that the MPC was running in what I call the aggressive or very aggressive WAN setting, where one of the sides of the computation was just consumer grade internet in the city of Chicago, and the server was a box in an AWS warehouse on the East Coast. And turns out consumer grade internet connections in the city of Chicago are not great, particularly when there's a Wi-Fi connection between their modem and the actual computer that is doing the computation. And turns out what happens is periodically you just get drops in connection for a couple of seconds, or maybe even a little bit longer than a couple of seconds. And our MPC was really built and tested not in this setting, not intended with periodic droppages and outage. And so what happened is the entire computation would periodically just fall over, and we weren't able to recover, and we'd have to restart the entire thing. As a result, additionally, I should say that we were doing a lot of very highly nonlinear computations here. And in particular, we want to do things like comparisons. When you have an arithmetic encoding of a value and you want to do a comparison, the thing you do is a bit decomposition. And that's actually a highly nonlinear operation. And so we needed lots and lots and lots of pre-processing and a lot of computation to kind of parse out these values. And we did absolutely no optimization on the front end whatsoever. So the combination of these two things meant that each actual MPC run that we did was between 50 and 30 hours long because they had to actually download and decrypt all these values. And also it crashed all the time. And when it crashes sometime in this 15 to 30 hour window, turns out you're asleep a lot of the time when it crashes, and you wake up the next morning and say, oh, we got to turn it back on and start at the beginning. And so many of our computations actually lasted up to a week. Turns out MPC doesn't need to, crypto in general doesn't always need to be blazing fast in order to be helpful and deployable in the real world. Big lessons learned here is don't defer choosing the actual computation you're going to run before you gather data. Don't do that. It was a terrible choice, huge mistake. And just a note that kind of our academic notions on WAN when it comes to kind of feasibility results of cryptographic computation are kind of goofy and not very real. When it came to actual data analysis, there was a script that I thought we were going to follow implicitly because I had read all the MPC literature and this is how this is supposed to work. Where first what you do is you gather your data, you run the MPC computation, you get out all these beautiful numbers, all this tabulation, and you're going to hand it to a data analyst. And the data analyst was going to look at it and make meaning from it. That's how it should work, right? Everything is great. And this is exactly how things went until eventually they came back to us and said, this was super helpful. We want to then go back into the data and ask these additional questions. And the problem is that this is an adaptive query to a private database. This completely breaks our notion of what's supposed to happen in MPC, where you predefine the computation. Now the computation is actually defined based off of the data, right? And all of our notions of privacy are basically toast. This is really challenging for me as a cryptographer because particularly I was being entrusted as the privacy expert in the room here. So they didn't know whether or not they were going to allow, they should be able to do this computation. They asked me, hey, Gabe, is it okay for us to run this computation? How am I supposed to answer this question? Right? This is a really, really complicated and nuanced question, one that involves understanding the needs of the actual survey, the needs of the community that we're serving, and on the other hand, trying to parse apart what the real concrete privacy risks of doing this computation are. Eventually, we did sit down, we had these discussions, we determined some of these computations that we were going to do. We then implemented those, ran a new computation, and a new data analysis could happen. And this happened, I would say, about 4 to 5 times. And this was really, really challenging for me to continually have to say, like, this is going to be the last one, right? And they'd say, yeah, for sure. And they come back 2 weeks later and say, okay, it wasn't actually quite the last one. I want to ask this other question. And I had to grapple with this over and over again. So some lessons here for me, and I think this is really applicable beyond MPC, but MPC doesn't give us the language to discuss the extent to which any given computation is going to be disclosive. And in general with crypto, right, your privacy is only as good as the definition that you write. And it turns out if you write a crappy definition, it doesn't inherently make anything more private to use cryptography, right? Because privacy is an abstract notion with lots of different interpretations and a lot of different contexts. And our definitions are really a firm mathematical rendering of one particular notion. One nice thing about MPC is that it required coordination and discussion. And there was no opportunity for unilateral action. So even if they wanted to go back in and run a computation, they couldn't do it without me. And similarly, if I wanted to do something, I couldn't do it without them. And that required lots and lots and lots of discussion, which I actually think was a structural power of this approach. When it came to data release, they built out, as I said, this 140-page report, lots of great stuff in here. One thing that happened just very, very shortly before they were going to release this is Mayank and I were sitting and reading a draft, and we finally got to the appendix, and we found 50 or 60 pages, that might be an overstatement, but many, many pages of tabular data of just raw results from the MPC that we had given to them. And we were actually concerned about the amount of these raw tabular results were eventually going to run up into data reconstruction problems. That somebody, if they sat down, put a SAT solver, took all this data in, would be able to actually reconstruct individual level responses to our MPC. And so we had to say, oh, wait, stop. Please don't release this to the public, because we know people who will take this data and who will try to reconstruct it as like a class exercise. And we don't want to do this. Slow down. And instead what we decided to do is we decided to integrate a differential privacy into those reports, which we just finished about a month or so ago. And this prevents some of those data reconstruction fears. Some big lessons here. So the norms around what kind of data gets released and in what formats is very field specific. From MMF's perspective, they were releasing this data to show everybody who's invested in the project that there was nothing up their sleeve. That's actually how they think about trust. Right? They want to make sure you can do your own analysis. You don't have to trust ours. From our perspective, by releasing this data, they're actually risking the privacy of the people who are responding to the survey. And these two things were in tension. And a lot of these norms are very often implicit, and they only really surface when there's a tension between these two different sets of norms. So it's important to understand what's going to happen ahead of time. From a feedback perspective, I'll say I'm very happy to say like there really wasn't any lies that I told you in the first version of this story. People are really happy and people are really excited about using MPC in order to do this. And we're actually going to be collaborating with them in the fall to do a second run of this analysis as well to try and get some longitudinal data over a couple of years. From my perspective, I like to think that because we approach this relationship as a real relationship instead of transactional, we were able to kind of recover from me being dumb. And I think that that was really important. Acknowledging that, yeah, I made a mistake, and we need to figure it out from here, and trying to, be truthful and humble in those contexts. So I'll just kind of sum up with 3 lessons because there's too many for you to remember. The first is this mismatch between what different fields think are the hard part of the problem or the interesting part of the problem, and the way this can impact your timeline in terms of deploying cryptography. One kind of big one is that cryptography as a whole doesn't really give us language to talk about whether or not a particular definition is a useful one or is the right one for a particular social context. And the third is that the norms around privacy and trust are very field specific and oftentimes are implicit and require kind of careful navigation in order to make sure that everybody comes away with something that they feel positively about. And so I'll stop there. I'm probably over time. And thank you to all of the many students who worked on this project with me as well. Thanks, y'all.